Good morning, students. So, after the completion of chapter chemical kinetics, now next chapter we will discuss is your electrochemistry. 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 So here you see. So electrochemistry. I think here we have two words. One is electro. Electro means I can say your electricity, and chemistry means we basically will discuss about the chemical reactions. Okay, chemistry means the chemical reactions we will deal with. So electricity and chemical relationship. That means this chapter, I think there is study of relationship between electricity and chemical reaction. Either from electricity to reaction or from reaction to electricity. So electrochemistry is the study of relationship between electrical energy and chemical energy, and the process of interconversion of one to other, converting electrical energy into chemical energy, chemical relationship, or converting chemical energy into electrical energy. That means doing the chemical reaction, producing electrical energy, or applying electrical current to carrying out the chemical reactions. So these two things are going to discuss here in this electrochemistry chapter. So electrochemistry is the study of interrelationship between electrical energy and chemical energy, and process of converting one into another. Okay, so what we say, what you have to electrical energy, your causing party, chemical reaction, okay, or chemical reaction producing what? Electrical energy. So two processes are there. In one process, we are applying electrical energy or electric current and carrying out the chemical reactions, different chemical processes. Other, what we are doing, we are carrying out the chemical reactions, different kind of chemical reactions. Basically, these are called redox reactions. And as a result of the chemical reactions, we are producing electrical energy. Okay, and for doing this one, we are using the devices called electrolytic cell. Okay, and for carrying out this one, we are using the device called electrochemical cell. Okay, so what is electrolytic cell, other electrochemical cell. So we have two processes carrying out with the help of two devices. One is electrolytic cell. In the electrolytic cell, what we are doing, we are applying the electrical energy and carrying out different kind of chemical processes. In the second one, we are taking an electrochemical cell. Okay, and with the help of this electrochemical cell, what we are doing, we are carrying out the chemical reactions and producing the electrical energy. Okay, and this process is called electrolysis. The electrolytic cell, where we are applying electric current and causing the chemical reaction. So the called what? Electrolysis. The process is called electrolysis, and this process where we are doing the chemical reactions and producing the electrical energy are basically called what? Redox reactions. So indirect redox reactions. So in this chapter we will discuss one by one all the factors okay, and things basing on these two, electrochemical cell and electrolytic cell. Now this whole process again involves one thing, that the electric current. So whether you go for the electrolytic cell, here what we are doing, we are applying electric current and causing the chemical reactions. Okay, and here in electrochemical cell what we are doing, we are doing chemical reaction and producing electrical current. That means now somewhere the most important thing we are dealing with is the electric current or electricity. Okay, so depending upon the flow of electricity or flow of electric current, so the substances are divided into different kinds. So that we will discuss first. So then after we will discuss about the electrolytic cell. Okay, let us discuss how the different kind of substances are divided on the basis of the flow of electric current. Okay, and we know what is electricity. Electricity is what? Is the flow of charges or the flow of ions. Okay, so depending upon the flow of electric current, the matter are divided into what? Two categories. One is what? Conductor. Other what? Non-conductor. Okay. So conductors are those through which electric current can pass through. Non-conductors are those through which electric current cannot pass through. Simply. And these conductors are again two kinds. One is what? Metallic conductor, and other what? Electrolyte. So what are metallic conductors? Metallic conductors are the metals or they are substances through which electric current can pass through in their solid state. And how the electric current is passing through different kind of conductors in this structure, that is a matter of discussion in physics. Okay. Now second one, the electrolyte. So these are substances through which electric current can pass through either in their fused state or in their aqueous solution. Okay. So what I can say, your current pass through in solid state like copper, like silver, like aluminum, like gold, etc. Okay, so copper, silver, gold, aluminum are the different kind of metals through which the electric current can pass in the solid state. Okay, now you know electrolytes. So electrolytes are those through which electric current can pass through either in their molten state or in their aqueous solutions. Okay, so and so current pass through. Okay, either in fused state or in what? Or in aqueous solution. And you see, when you put the substance in water, okay, it will conduct electricity, or when you fuse it, when you melt it, that will conduct electricity. That is called electrolyte. Okay. Similarly, this non-conductor which cannot conduct electricity. Okay. That again non-metals. That means those substances through which electric current cannot pass in the solid state. Okay, or non-metals, phosphorus, sulfur. Okay, now your non-electrolytes. So non-electrolytes are those. Non-electrolytes are those. Non-electrolytes are those through which electric current cannot pass either in the fused state or in their aqueous solution state. For example, I take easy sugar, urea. Okay. Now, about electrolyte, electrolytes can again have. So this you can take example of can take example of NaCl, okay, A3NO3, okay, copper sulfate, H2SO4, okay. So NS4OH, are kind of electrolytes, and these electrolytes can be of two kinds of strong electrolyte and your weak electrolyte. Okay. This can be strong or this can be weak. So strong electrolytes are those which undergo complete ionization. That is here the degree of dissociation alpha is main equal to 1. And weak are those where the degree of ionization is less than 1. So alpha less than 1. So this is your classification of your metals on the basis of passage of electric current. Again I am repeating, on the basis of passage of electric current, whether electric current can pass through or not, the metals are conductor or non-conductor. Conductors are those which can conduct electricity. Non-conductors are those which cannot conduct electricity, or which doesn't allow the passage of electric current through them. Now, conductors can be two kinds: metallic conductor and the electrolyte. Metallic conductors are those which can allow the passage of electric current through their solid state. Current can pass in the solid state, like copper, like silver, aluminum, gold, and many are. And electrolytes are those which can allow the passage of electric current through the fused state or through the aqueous solution. Okay, so either we can put NaCl, either you can melt NaCl, or you can put NaCl in water where it will conduct electricity. So electrolytes are those which can conduct electricity either in the fused state or in the aqueous solution. So you take an NaCl, silver nitrate, copper sulfate, sulfuric acid, ammonium hydroxide, sodium acetate, many are there. And these electrolytes again have two kinds, strong and weak. So if the degree of ionization alpha percentage nearly equal to 1, that is called strong electrolytes. If it is less than 1, then you are weak electrolytes. Basically, the strong acid I can say the sulfuric acid, H2SO4, HCl, that we can take in the strong electrolytes. Okay, and weak bases or weak acids like ammonium hydroxide you can say, or sodium acetate you can say. Okay, so these are the weak electrolytes where alpha is less than 1. Okay, so this is about conductors. About non-conductors, so those who cannot conduct electricity, like non-metals and what the non-electrolytes. So non-metals are those which cannot allow, doesn't allow the passage of electric current through the solid state. Like phosphorus, sulfur I have done here. Okay, and non-electrolytes are those where electricity cannot pass even if in their feed state or in their aqueous solution also, like your sugar solutions, urea solutions, etc. Now, when you come to here, metallic conductor and the electrolytes. So metallic conductors can conduct electricity, and so also electrolytes. Okay. Now, what is the difference between these two? We know electricity or electric current means what? Is the flow of electrons, flow of charges, flow of ions. Okay. So when you compare this metallic conductor and the electrolytes, okay, if I write here metallic conductor, metallic conduction, okay, and your electrolyte, okay, metallic conduction and your electrolyte. So what happens here in this metallic conduction? In metallic conduction here, the flow of current is what? It is due to the flow of electrons. Here in metallic conduction, the current is due to what? Flow of electrons. Whereas in electrolyte, the current is due to the flow of ions. Okay, what is flow of electrons? Here what? Flow of ions. Number two, when current is passing through a conductor, no chemical change is occurring. Simply the current passes due to flow of electrons. But when current is passing through an electrolyte, chemical reaction occurs. So there is a chemical change. Okay. So no chemical change. No chemical change. Here what? Chemical change. Now, again, so when there is a flow of current through the conductor, as there is no chemical change, there is no transfer of matter. The matter remains as usual in their usual states, usual positions. No transfer of matter takes place. But when its current is flowing, so the electrolytes, the matter transfers from one to other. Okay, so there is a change of mass. Okay, so no transfer of matter, and here what? Transfer of matter. Okay, so no transfer of matter in case of what? In case of metallic conduction. What? Transfer of matter in case of what? Electrolytic conduction. Next one. When current is passing through the conductor, if you raise the temperature, then the electrical conductivity will decrease. Whereas if you increase temperature in case of electrolytic conduction, then the conductivity will increase because of the more and more ions will move. Okay, conductivity decreases with the increase of what? Temperature. What? conductivity increases with the increase of what? Okay. So when you compare the metallic conduction and electrolytic conduction, what happens here? First of all, we have seen the metallic conduction is due to the flow of electrons, whereas the electrolytic conduction is due to the flow of ions. Next we have seen the metallic conduction, so there is no chemical change, but electrolytic conduction there is a chemical change. Third one, so there is no transfer of matter in case of metallic conduction, but there is a transfer of mass, that is the matter in case of electrolytic conduction. Then so when in case of metallic conduction, so the conductivity decreases with increase in temperature, but in case of electrolytic conduction, so the conductivity increases with increase of temperature. So these are the basic differences between the metallic conduction and the electrolytic conduction. Also the now also you can compare with electrolyte and the non-electrolytes. Already we have discussed electrolytes and non-electrolytes. So you can compare. Electrolytes are what? Electrolytes are the substances which can conduct electricity, in their what? In their fused or in their aqueous solution, in their fused state or in their aqueous solutions. Whereas non-electrolytes are those which cannot conduct electricity in their fused state or in their aqueous solution state. Okay. Electrolytes are generally ionic compounds in nature, but these non-electrolytes are generally covalent in nature. When electrolytes conduct electricity, or when they melted or when they put in aqueous solution, so they split up into ions, but the non-electrolytes are not splitting up into ions. Okay. So these are about electrolytes, non-electrolytes, conductor, non-conductor, etc. Okay. How the metals are being classified on the basis of the flow of electricity. Clear? So now we will discuss about how the process of electrolysis is being carried out. Okay. Now see electrolysis. So already we discussed. I have told you, electrolysis is the process of converting or creating a chemical changes by applying the electric current. So the process where electrical energy is causing the chemical changes is called electrolysis. So electrolysis is the process of decomposition of an electrolyte when electric current is passed through it. Right? So, and for this process of electrolysis, we are taking a device called electrolytic cell or electrolytic tank. Okay. So electrolysis is the process of decomposition of an electrolyte when electric current is passed through its fused state or in aqueous solution. This is to be underlined. Now we see when the electrolyte in its phase state or in its aqueous solution. That means the electrolytes are already in the ion form. So when you take the electrolyte and fuse it is splitting up into ion. Now when you pass the electric current, the ions will dissociate, they will separate, and they will migrate, they will move. That is called electrolysis. Okay, so already we have the fused state of the electrolyte, or we have the aqueous solutions of the electrolytes. That means they are already there in the ion state. Now when you apply the electric current to such fused electrolytes or aqueous electrolytes, then the ions will separate. Okay, they will dissociate, separate, and will migrate. Right? And for doing this entire process, what we are doing, we are taking a cell called electrolytic cell. Let us discuss how this electrolytic cell is being made. So, electrolytic cell. So here we are taking a vessel here. We are taking a vessel here. Okay, a vessel made up of glass called electrolytic tank. Okay, the vessel made up of glass. Now this electrolytic tank, okay, consisting of two electrodes. Okay, two electrodes. Okay, copper, silver, gold, aluminum, platinum, palladium, any we are taking the electrodes. Okay, they are called electrode. This is also electrode. Okay, now these electrodes are connected to a battery. So, positive, negative. So these two electrodes are connected to the two ends of a battery. One is to the positive end of the battery and other to the negative end of the battery. So the electrode which is connected to the positive end of the battery is known as anode. This is your electrode anode. Positive electrode called also anode. Okay, and the electrode which is connected to the negative end of the battery, called the negative electrode or the cathode. Negative or cathode. Okay, and this is the battery setup. Okay. Okay. Now, in this electrolytic tank, we are taking an electrolyte. An electrolytic solution. But we are taking an electrolytic solution. This is what we electrolytic solution. Electrolyte we are taking aqueous solutions or crystal. This is what electrolytic cell. So this is the setup of the electrolytic cell. Okay. Now what is happening? So we have the electrolyte tank here, we have the electrolytes, we have the electrodes, and also we have the battery. Now, when this is your key substance. So when you close the key, that means when you connect this battery to the positive end of the battery, now what happens? Now the electric current will flow through this setup. Ideally, now what will happen? In this electrolyte tank, we have the electrolytes. Now, suppose we have these electrolytes A, B, suppose A, B. Now we have A plus and B minus ion. Okay. Now, when you pass the electric current, this electrolytes will split up into the positive and negative ion. Okay, that's the cation and anion, and these cation and anions will migrate towards the oppositely charged electrons. Okay, so what happens here? Now the electrolytes, we have the positive cation and we have the negative anion. Okay, so we say on passing current, electrolyte splits up into positive cation and negative anion. Okay. Now cation goes to cathode and anion goes to cathode. You see, so when you pass electric current, the electrolyte splits up into positively and negatively charged ion. Okay, that is the cation and anion. The positive ion is called the cation value positive, and the negative ion is called your anion. The cathode electrode is called what? The negative electrode, and the anode electrode is called what? Positive electrode. So what happens here? The ions are migrate towards the oppositely charged electrode. Okay, so here the cation will go towards cathode and the anion will go towards the anode. Okay, so we have anode. This is the anode here. So this is your cathode, your anode. So cation will go to cathode. So we have the positive ions here. With the positive ion here, positive ions here. Positive ion will go to cathode, and we have negative ion here. Negative anion will go to what? Anode. Negative ion to anode, negative ion. So cation goes to cathode and anion goes to anode. Now when the cation will go to cathode, what will happen? What it will do then? Now cation is having a positive ion. So when it goes to cathode, it receives electron from the cathode and converts into neutral atom. Okay. Similarly, when the anion goes to anode, loses electron there, okay, and converts into neutral atom. After converting into neutral atom, they may undergo some secondary changes. So when cation goes to cathode, then it receives electron, undergo reduction, okay, and that may deposit there, and when anion comes to anode, loses electron, undergo oxidation, okay, that degrades there. It may remain as such in neutral state, or it may undergo some secondary changes. Okay, so cation, okay, goes to cathode, loses oxidation. It goes to cathode, accepts electron, that is undergo what? Undergo reduction. Okay, and your anion goes to anode. Okay, loses electron, undergo oxidation. So reduction takes place at the cathode and oxidation takes place at the anode. Okay, so here is the cathode. Okay, here in cathode, the anode, here oxidation, and here reduction takes place. Okay, now so this is the way how the process of electrolysis is going on. Let us discuss this with the help of an example. Okay, let us see. Is that clear? So again I am summarizing. Electrolysis is the process of decomposition of an electrolyte when electric current is passed through its fused state or in the aqueous solutions. Okay, so for doing this we are taking an electrolytic tank or electrolytic vessel which is made up of glass. In this glass vessels, two electrodes are taken and the two electrodes are connected to the two end of the battery. The electrode which is connected to the positive end of the battery is known as the anode. Okay, positive electrode, and the electrode which is connected to the negative end of the battery is known as the cathode, that the negative electrode. Then after, when electric current is passed through this through the anode, what happens? The electrolyte splits up into positive and negative ions, that is cation and anion. After that, these ions are migrating towards the oppositely charged electrode. The cation is migrating towards the cathode and the anion is migrating towards the anode. When the cation goes to cathode, there it receives electron, undergo reduction, may convert into neutral atom, may remain as such, or may undergo some secondary change. Similarly, the anion then goes to anode, loses electron there, undergo oxidation, converts into neutral atom, may remain as such, or may undergo some secondary changes. Okay, for example, now see, let us discuss the electrolysis of some typical electrolytes. Okay, for example, number 1, if I take electrolysis of fused NaCl. Let us take electrolysis of fused NaCl. So when we have fused NaCl, that means what? We have NaCl, we have Na plus Cl minus. We have what? Na plus Cl minus. NaCl is solid. Okay, so Na plus Cl minus. Now at cathode, what happened? We have the Na plus and Na plus. Okay, so cathode is rich in electron, so Na plus electron you have sorry. Okay, and at anode we have Cl minus. Okay, minus electron. Cl. Now Cl plus Cl divided Cl2. Okay, so together. So what is 9 into 2, right? 2 Cl minus 2 electron. What is Cl2 minus. So when we are doing the electrolysis of fused NaCl, will get what? sodium atom the cathode and chlorine gas at the anode. Okay, so the chlorine gas will liberate at anode and sodium will be to cathode. Now, if I take suppose aqueous solution of NaCl. So here you see, when we have only one cation or only one anion, the cation goes to cathode and the anion goes to anode. Now when we have, suppose we have more than one cation or we have more than one anion. For example, see here aqueous solution of NaCl. Here what happen? NaCl, okay, divided Na plus Cl minus NaCl aqueous, Na plus aqueous, Cl minus aqueous, and we have, because we have aqueous solution of NaCl, so here what will happen? We have H plus O minus. So here you see, from the NaCl we have Na plus and Cl minus, and again from the H2O we have H plus and O minus. Now we have Na plus and H, two cations are there. We have Cl minus and O minus, two anions are there. Now there will be competition. But at an electrode, only one cation will discharge. At the cathode, only one cation will discharge, and at the anode also only one anion will discharge. Now, who will discharge them? That is decided by the selective discharge of ions of fluid. So we have to select. So this selection of ions depends upon two things. One is the position in the electrochemical series, and other the nature of the electrode. So we have the electrochemical series. Where different electrodes are arranged with decreasing order of their standard reduction potential. So if we have A and B, two electrodes are there, we will find which is having the more reduction potential. That will undergo reduction at the cathode. Similarly, the reverse will be there for the anion. Okay, so electrochemical series is the series where the different kind of electrodes are arranged with the decreasing order of their standard reduction potential. From that series, from the position of the electrodes, we will find out which is having the lower positions. Those which have the lower position will have the lower reduction potential. Okay, so from that position we will decide that which electrode will discharge at the cathode and also at the anode. Okay, so let us see that electrochemical series. Okay, the electrochemical series So here only a small portion. Here only a small portion we will discuss. Like for K plus, let's see, K plus Ca2 plus Na plus Mg2 plus Zn2 plus Ap2 plus Pb2 plus H plus CO2 plus Ag plus AO3 plus. So this is the ease of discharge. This I have taken for the ease of discharge of electrons. So here, if I say Na plus NH plus, here H plus is having higher reduction potential as compared to Na plus. So from the electrochemical series, here I have arranged the increasing order of ease of discharge. Which have higher reduction potential, that will undergo reduction, right? So, and this is the electrochemical series where the here electrodes are arranged with the ease of discharge potential. Okay, so here H plus is having the higher reduction potential as compared to Na plus. So when I have Na plus and H plus, then the H plus will discharge as compared to Na plus. Similarly, I can also say negative answer like what SO4 2 minus O, like for SO4 2 minus O, we have NO3 minus O, we have OH minus O, we have Cl minus O, we have Br minus O, and also we have I minus for the negative ions. Okay, for the negative ions. So if you have suppose Cl minus and OH minus, then what do the Cl minus ion will discharge. Okay, so now see here we have NaCl giving what Na plus Cl minus, and we have H2 giving what H plus and OH minus. In this case, we have Na plus and H plus. If you see this electrochemical series, now the ease of discharge is increasing in this way, increasing, and who is having higher? H plus is higher. So H plus is having the higher discharge potential as compared to your Na plus. That's why here H plus will discharge. So what happens at cathode? We have H plus electron H2. Okay. Now H2 plus H2 what is H2. So 1 to 2. What I can write? 2H plus 2 electrons is what H2. Okay. So H2 gas will remain at the cathode. Now when you come to anode, you see we have what Cl minus and OH minus, two anions are there. And if you see here the Cl minus ion will have higher discharge potential as compared to the OH minus. So the Cl minus ion will discharge here. So what I can write at anode, I can write here. So here I can write at anode, what happened? Because Cl minus is having the higher discharge potential. So what happened? Cl minus electron value Cl, then Cl plus Cl value Cl2. So into 2, I connect 2 Cl minus, okay, minus 2 electron is what Cl2 plus. So when there will be electrolysis of aqueous solution of NaCl, the H2 gas will liberate at cathode and Cl2 gas will liberate at the anode. But when we have the filled NaCl, fused NO cell, we have sodium metal cathode, and we have Cl2 gas at anode. But when you take aqueous solution of NaCl, we have hydrogen at cathode and chlorine at anode. Okay, so this is due to what? Preferential discharge of the anions and cations. Okay. Now see, so next we will discuss result here depending upon this electrochemical series. Okay, so those ions which are in the higher discharge potentials, they will undergo discharge at the cathode and anode respectively. Clear? Now, number 2, and another thing we can discuss here, how this electrolysis, this depends upon the nature of the electrode. See, the electrodes, okay, nature of electrode. We have nature of electrode. We have 2 kinds of electrode. We can say attackable and non-attackable. So attackable electrodes are those where the electrode is taking part in the chemical reaction. Like copper in copper sulfate, like silver in silver nitrate. Okay, so if we have copper sulfate electrolyte and we have made the anode as copper, okay, then the copper electrode will take part in the reactions. At anode, the copper will dissolve into CO2 plus ions. It will undergo oxidation. Now the anion will not migrate towards anode. In the anode, copper itself will undergo oxidation. Similarly, if I have Ag in AgNO3, okay, what happens? The anion, that means from the electrode AgNO3, we have the Ag plus and NO3 minus. Now the NO3 minus ion will not migrate towards anode. The anode Ag will undergo oxidation into Ag plus. That is called attackable anode. And here non-attackable, you can have platinum and palladium, Pd. So these are non-attackable anodes. Now let us discuss the electrolysis of copper sulfate using copper electrode and also electrolysis of copper sulfate using an inert electrode. Okay, let's see. Electrolysis of copper sulfate using copper electrode. Okay, so we have number 1, electrolysis of aqueous solution of copper sulfate using copper electrode. Okay, so we have copper sulfate CuSO4. Now Cu2 plus SO4 2 minus. Okay, and we have H2O. On this we have H plus OH minus. Okay, now we have copper electrode attackable. So what happens at cathode? To cathode will have what? Cation. At the cathode, the cation will go, and here we will CO2 plus, and we have CO2 plus and H plus are the cations. Now CO2 plus will have the higher discharge potential as compared to what? The H plus. So what happens here? At the cathode, CO2 plus 2 electron is what? And at anode, because here we have the copper electrode attackable. attackable electrode is there. So here the non-anion will be minus towards the anode. Now the copper itself Cu minus 2 electrons will be given. So Cu2 plus ions will liberate at the anode from this copper electrode. Okay, and at the cathode the Cu2 plus will convert to Cu. So at the cathode copper will be deposited, and here this copper will undergo oxidation, right? So this is the electrolysis of your copper sulfate solution. So using whatever copper electrode that's attackable. Now if I take a non-attackable anode, okay, suppose electrolysis of copper sulfate solution using platinum electrode, So what will happen here? CuSO4, you are Cu2 plus SO4 minus, okay, and we have H2O, H plus O minus, okay. So you can take your aqueous, Cu2 plus aqueous also H2O, aqueous, this is your aqueous into solid, okay. Solid, aqueous, equivalent. Okay. Now H plus O friends. Okay. Aqueous. Now at cathode. Cathode already we know we have this Cu2 and H plus are there. So because according to the preferential discharge theory, this Cu2 plus is having the high discharge potential. So this Cu2 plus will discharge here. So what happens? Cu2 plus 2 electron aqueous into S. Now at the anode, here the electrode is what? Platinum, which is what? Non-attackable. So what will happen here? The anion will migrate towards the anode. And we have here SO4 minus and O minus. Two anions are there. And if you see this preferential discharge series, if you see the discharge series, the OH minus ion will be higher discharge potential. So what will happen here? At anode, what happen? OH minus aqueous minus electron part OH plus OH H2O plus O and O plus O. And we see O2 gas will be. So here I can multiply by 2, here I can by 2. Okay, so what I made 2 into 4. So 4 OH minus 4 electron. This what no 2 H2O plus 2. So O2 gas will liberate at the end. So when we will carry out the electrolysis of copper sulfate solution using copper electrode, attackable electrode, what we are observing at cathode we are getting the copper and at anode the Cu2 plus ions are being liberated. Okay, now when we are doing the same copper sulfate solution electricity using an non-attackable platinum electrode, what we are observing, we are getting copper at the cathode, but at the anode the oxygen gas is being liberated. Okay, let us see an example of electrolysis of silver nitrate. So using silver electrode and using non-attackable electrode. Okay, now see if I take electrolysis of silver nitrate using silver electrode. Okay, electrolysis of silver nitrate using silver electrode. Okay, so when you do this one, what will happen? AgNO3 will give what? Ag plus plus NO3 minus aqueous. Okay. Now also we have water H2O, H plus plus OH minus aqueous. Okay. Now at cathode, at a cathode we have what? We have Ag plus and H plus. We have Ag plus and H plus, and this will have the higher discharge potential as compared to what? The H plus. So what happens? Ag plus electron particle. Ag. Okay. Now at anode, because we have the silver electrode attackable. This is what? Attackable. When we have the attackable electrode, okay, that moment so the anion will not migrate towards anode. The anode itself undergo oxidation. What happens? Ag minus electron particle. Okay. Now you can do the same thing with help of what? Non-attackable anode, that your platinum electrode. Okay. Electrolysis of AgNO3 using platinum electrode. Okay, what happened? Solution. AgNO3, Ag plus NO3 minus aqueous solid. H2O, H plus plus OH minus aqueous. Okay. Now at cathode. Okay. What happened? Ag plus and H plus. We have Ag plus electron part. Now at anode, we have NO3 minus and we have the OH minus. So this OH minus will migrate. What happened there? At anode, OH minus is equal to OH plus OH, H2O plus O, O plus O, O2. Okay, so into 2 you get what? 4 OH minus and 4 electron, what? 2 H2O plus 2. So then the electrolysis will electrolysis for silver nitride will be carried out because some silver electrodes, so we are getting silver at a cathode and Ag plus at anode. But when we are doing the same thing by using inert electrodes, okay, like platinum electrode, then what is happening? We are getting the silver at a cathode, but at anode oxygen gas is being liberated. Similarly, so many other electrolysis also you can carry out. Okay, thank you.